This video will explain the steps involved in creating a Python program which will convert a binary number to decimal. The first thing that we need to do is put down some comments to explain what this program is all about. Now, it's really important that you actually create the program at the same time. Now, you can either watch the video fully first and then go back and go through the video and actually program it. It's the only way that you're going to improve your programming skills. If you actually program, watching it, you're only going to get 5% from that. You'll get 95% from actually creating the program, testing it, checking for your own errors and learning from it. I'm using Thorny to create this program in, but you could use Visual Studio Code. So in Thorny, let's start with a multi-line comment, which is triple speech marks in Python. I'll say this program will take in a string user input of a binary number. That's the first thing the program's going to do. The program will then validate the number to make sure each character is a 1 or 0. If the user enters a character that is not a 1 or 0, then they will be prompted to re-enter a valid binary number. And as we know, binary numbers only contain 2 digits, 1 and 0. Right, so let's do a basic design of this program, and I'm talking about the kind of large steps that the program has to carry out in the correct sequence of events. So the first thing to do is validate user input. It must be a 1 or a 0. That's the first thing. Second thing that we need to do is we need to reverse the string by slicing and flipping the characters. There's a special Python way of doing this, and I'm just going to put it in here in the comment just now, but I'll explain it fully when we get to that part. Now, I'm going to put in here that -1 means reverse the steps. The negative means reverse, and the 1 means step backwards 1 at a time. Right, the next thing that needs to happen is, and I'm using the correct terminology for this, we need to iterate over the string. So that means loop through it. And we'll use a fixed loop for this because we know how many characters are in the string. And as we iterate over it, we need to do a couple of things. So the first thing to be done is we need to convert each string character to an integer. And the second thing that we need to do is we need to add, and I'm going to put in this append because that is the technical term for adding a value to the end of an array data structure. So append the integer to the integer array. Now, we've not really talked about an array data structure, and I will do that when we get to actually program it. Now, the next big step is step 4, which is we need to iterate over the array this time. And this is a running total algorithm. So the algorithm means that the steps that you carry out are specific steps for a running total. As we're iterating over this array, we need to do a couple of things. So the first thing that we need to do is we need to test if the location, if the array location, so we need to test if the value located at the array location referenced by the loop index has a 1 in it. If it does, then we need to calculate the place value and add it to the running total. And the way we calculate this, I'm just going to put it in here as a wee note. So because there is only a digit 1 or 0, it'll just be 1 times base to the exponent, where in our case the exponent will be we're going to use the loop index for this, and that's why we reverse the string so that the loop indexes match up. And if there isn't a 1 there, then we're not going to do anything. Right, so that's the main steps. Now there's one more thing to talk about before we move on, and that is specific Python operators used here. So we've got the power operator, and that is written with 2 stars, and we've got the reverse string, and that is your square brackets with the 2 range values, and then the negative, which means reverse, and the 1, which means reverse 1 step at a time, because there's lots of different ways that you could slice and step through a string in Python. Okay, so let's get our variables in, and now we've got a data structure to deal with as well, the array. So let's say binary num, and that's going to be a string value. The next one is binary num validated, and we need this because we definitely need to check that the user input is either going to be a string made up of characters 1 and 0, and the only way we can do this is iterate over the string inside the validation while loop. So we need to use a Boolean variable for this, and we'll set it up to be false. See how I used a capital F for that and it's changed colour? That's how Python defines the Boolean values. True would have a capital T. Right, what else do we need? We're going to need a reversed binary just to hold the number after it's reversed. Now, just as in the other video where it actually explained the process of converting a binary number to decimal, we're going to use the 3 terms: the base, the place value, and the exponent. So in this instance, the base will be base 2, because that's binary is base 2. It's a number system which uses base 2. And because we're using a running total algorithm, I'm going to call my variable, which instead of calling it running total, I'm just going to call it running decimal, because we're converting this to a decimal. Now this will be an integer. And lastly, we're going to create an array, and it's an array which will contain binary characters. And so the array is square brackets. That lets Python know that it's a data structure. Now technically Python does not have an array data structure. It has lists, it uses lists instead, but for our purpose, for our course, we're talking about arrays, and this is how we would define it. I'm just using a prefix there, r_binary, to let me know that this is an array. Now this is an empty array, there is nothing in it at the moment. And as you know, or you will find out from your studies of arrays, one of the things about them is they can only store data of the same type. So you can have an array of string values, or an array of integer values, or an array of Boolean values, or an array of real values. But what you can't have is an array where the values inside it are a mix of string, Boolean, real, and integer. So let's move on now. That's us defined everything that we're going to need to store. So these are the memory locations which, as soon as this program starts to execute, line 23 to 28 will instruct the processor to reserve these memory locations in RAM for the duration of the program execution, because we are going to be using the values that are contained at those memory locations to process with. So let's get our input sorted out here. So input validation, algorithm. So, and it will test the user input string to make sure it only contains characters 1 and 0. That's really important. So we are going to use a while loop for this. Now normally in your input validation you would get the input first and then you would test it. But because this is a loop, and inside that loop we're going to have to iterate over each character, it's better to use this binary num validated here on line 24, this variable to control the loop. So let's do that. So while, because input validation always starts with a while loop. So while binary num validated is equal to false. Right, so because I've set it up to be false when I've declared it, that means this is going to execute the first time. So as soon as we go into this, the first thing that we need to do is set binary num validated to true. So binary num validated is assigned the value true. Yeah, and then after that, what we're going to do is iterate over each of the characters within the string that the user is about to input, and if they put in a wrong character, we will set binary num validated back to false, so that when this loop starts to iterate again, it goes back up and tests itself on line 33. If it's been set back to false, it will go back into it. Otherwise, if it's true, it will exit out of it and we can move on. So next thing we want to do is we want to get the user to input the number that they want to convert. So binary num is assigned input. Now we don't need to turn it into an integer or anything, because the input does return a string data type. So enter a binary number made up of ones and zeros. Okay, so you've gave them the message and you've told them what you're going to allow. So it should be ones and zeros. Right, so that's this binary number, this variable binary number, after this line has executed, will contain a string made up of ones and zeros. Just to reiterate, line 35 is an assignment statement. This single equals means assign, and how it works is the right hand side of the assignment statement is executed first, and the result is stored in the variable on the left hand side of the assignment statement. Now let's just put a test in here, and we'll just say test and binary num. Contains, and then we'll add on, using the concatenation operator, whatever's stored in the string binary num. So let's save this. Now I've saved my file as binary to decimal conversion.py. So you do the same. So enter a binary number made up of ones and zeros. So I'm going to go 110 and test binary num contains 110. So we know that's working at this point. Now we'll iterate over the string. So we're using a fixed for loop because we know how many characters are in the string. We're going to test its length, and that the length of it will be how many times we iterate over it, how many times we loop through the string. So for index in range, and it's the length of the variable binary num, because you can iterate over the string data type. It's kind of like an array of characters, and at each location within that string we're going to test the character. So we say if binary num, and we use the square brackets for each character, and the character is index. So see how we've said in line 37 here, for index in range. This index is used as a variable. It starts at 0, and it will, every time this for loop goes round, 1 will be added to it, and it's a variable that's used to count how many times you've iterated. So we can use it to go into position 0, position 1, position 2, position 3 within the string. So the first time it goes round, it's going to look at the first character, and it's what we're testing for, not equal to. So if it's not equal to a 1 and binary, now remember you have to do both simple conditions here, binary num index is not equal to 0, then we're going to set binary num validated to false. Is assigned false. Oops, capital F. Okay, and that's it really. That's all we need to do for this. So inside this for loop, it will go round every character, and if the character is not a 1 and it's not a 0, then it's going to set this binary num validated to false, and then it will go back up to the top of the while loop, test this condition again, and if it is false, it will come back into this loop. So this loop could go on forever if the user does not put in the correct data. So let's test it and see if this validation is working. So Control S to save, then F5 on your keyboard to run it. So we'll test it that it is working, and we'll put in our 110 and hit enter, and that's working okay. So that's binary 6, isn't it? So that's 110 is the equivalent of a decimal 6. Right, so that's working now. We'll test it again. So click back up into your code and then press F5. This time we'll put in a strange number and hit enter. and it's told us 231 because this is our printout here on line 36, we're still printing out, but it's went back into enter a binary number. So this has been set to false because this if wasn't a 1 and it wasn't a 0, so it set the binary num validated back to false, which meant when it came back up to the top of this while loop and this condition was true, yes, binary num validated does indeed equal false, then it was forced to go back in and go through this process again. And if I put in 45 this time, it's going to force back in. Yeah, even although on line 34 when you go in here, the first thing you do is set it to true because you've came back down into this loop and you're testing each character. The same thing happens again. So even if I go 1 1 0 0 0 1 1 1, everything looks fabulous, and then a crazy 2 gets added in, when I hit enter, it's going to ask me to re-enter because this 2 is not accepted and it's forced this binary num validated to be set to false. So to get out of it, you need to put in proper binary. And there we have, we've exited. So we now know that our validation is working correctly. We can hashtag out this comment out line 36, that test, because we have tested it and we know it's working. So we can move on. Next thing we want to do is, let's see, so we've validated our user input. Next thing we're doing is reversing the string, slicing and flipping using this special Python syntax. So we'll come down here and we'll put a comment in to say reverse string of binary number inputted by user. Right, so to do that, what we have to do, we've got a variable, haven't we, called reversed string. Let's just check that it is there, reversed binary num. I'm going to copy that, Control C, so that I get the spelling correct. We pop it in here, and I'm going to assign to it my binary num. I'm just going to copy that as well. Control V, and put in my, so that means start of the range, end of the range, reverse it, and step back one at a time. Now, if we need to test this, let's go down into our shell. I'm going to clear that. In our shell, we can do a wee test. So let's say we have let's say a variable called name, and we give it Barney, right? And we want to see Barney reversed. So what we can say is name, boom boom, -1, square bracket, and there you are. Now, next thing we want to do, we could test this in actual fact. That would be quite a good thing to do. So let's do print test reversed binary num, and we will concatenate onto it reversed. It's still a string, so we don't need to use the cast predefined function str. Right, now let's just uncheck this for a wee minute, so that we know what the input is. Okay, and this time we'll put in 1 1 0 0 1 0 1. So 1 0 1 0 0 1 1. So it's definitely reversing it. So we've now tested. So we can comment out both of those tests so that our program doesn't need to keep doing that as we go through it. Let's see, what are we going to do next? Next, we have to iterate over the string, loop through it, and as we're iterating over it, we want to convert each string character to an integer and add or append to the integer array the integer character. Okay, so let's do that. So let's put in a comment to say what we're doing. So we're going to iterate over the reversed string and convert the character to integer, and at the same time we're going to append integer numbers to the array. So for index in range, and it's the length of the reversed binary num that we're going to use, just so that we've got the right length of characters. And as we go through this, what we're going to say is R binary, so array binary, that's the name. If we look back up here, this is the name we gave our array, R binary. So I could have copied that. I might just do it Control C just so I get the right spelling. Control V. And instead of using the assignment statement to assign to it, we need to say dot append, because it's an empty array. It doesn't have any locations at the moment. So we need to just add data to it, and it will be added to a new location within the array. And this time, because it's not just the string, we want to store it as an integer, so we do need to use the int predefined function to cast the string as an integer before it is then stored in the R binary array. So append has got its own brackets, and inside append we've put our int, and inside the int brackets we're actually going to put the location. So it's reversed binary num is the name of the string, and we want a character in the string, not the whole string, so it's index. So remember, this index is used as a counter variable, a loop counter, and we're using it here to go to the first time this loop goes round, it will go to the first character in our binary, reversed binary num. The next time it goes round, it will go into the second character, and so on. Right, so let's test this. And what we'll do is we'll print out, and we'll say test R binary. And what we'll do is we will add on R binary to it. Now I've used a comma this time. I don't want to turn it into a string because I want you to see the square brackets that to let you know that it is an array. So let's save that and run it. Actually, I'm going to clear that, and then I'll do it. So F5, okay, enter a binary number, so I'm going to go for 11001. Right, now we've commented out the other two print statements, so what we're seeing here is the number that's already been flipped and then turned into an array. And then added to an array, and each of the characters are now treated as numbers. And you can see here the square brackets that let you know that it's an array. So it's one memory location in RAM which is storing all of this data. And the memory location is R binary, and it's got all this data inside it rather than individual variables, memory locations for each one of these. So it's making your program a bit more efficient, and it's not using as many system resources. Now, by looking at this, I know that the data inside this array, these are integer values. So let me show you what it would look like if we changed this code slightly and we took off this int. So I'm just going to take that predefined int off there and that extra bracket, and I'm going to save it. I'm going to use the same 11001, and you'll see the difference that it makes. So 11001, and run it, and this time we do have our array binary. It is full of data, but the data type of the data is characters. Do you see that? Because it's got the speech marks. So this one here, the previous test where we used that int predefined function to change this string into an integer, this is how you can test to make sure that's worked, by looking at each character to see what data type it is. Okay, so let's go back up and change that back to the way it should be. So inside the append, this reversed binary num character needs to be turned into an integer, and it needs its closing bracket. Good. Right, let's do one final test just to make sure it's working. So 1100101, and yep, we're back. We've got our array and it's got integers in it. Good. So I'm going to clear that. So what's next? Let's see. So we're at step 3, we've just completed that. We've added, appended our integers. Next is step 4, iterate over the array. This time it's a running total algorithm. So you're going to test if the value located at the array location referenced by the loop index has a 1 in it. If it does have a 1 in it, you're going to calculate the place value and add it to the running total. Right, let's do that. So let's put a comment in to say what this code is about to do. I always do that. You'll be surprised that when you go back to look at this code in a few months' time, you won't have a clue what the code does, what it means, if you don't comment it. Very important to comment your code. First of all, it's forcing you to write down in a comment what's actually happening, which is helping your brain to understand what you're doing. So it's actually benefiting you in the long run if you get into the way of commenting. Any assessment materials that you hand in, you will get marked for the quality of your comments, because they're a way of showing your knowledge. Okay, so what do we want to say? So we're going to iterate over the array, and at each location we will calculate the place value, and then we're going to add the place value to the running total variable, which will eventually represent the decimal equivalent of the binary number. Now, I said for step 4 up here, let's go back up and look at this for a wee second. I said that at this location we were going to test each of these numbers to see if it had a 1 in it, and if it did, we were going to do this calculation. But I've decided that perhaps it would be better if we didn't do that extra test, because that's adding overhead, isn't it? That's adding processing calculations which might not be necessary. So we might actually make our program more efficient if we just write down, because 0 times base exponent will return 0, won't it? So you're either going to multiply it by a 1 or you're going to multiply it by a 0. And what contains the 1 or the 0 is actually the location in the array that contains the 1 or the 0. So whatever the value is in that particular location in the array, we're just going to multiply that. What we want to put in here is for index and range, and the length of our array, we can use the len function to test the length of the array, and it will return how many values are in the array. And the array is called our binary. So what we're going to say is, when we've got a variable up here called running decimal, let's just copy that so that we get the correct name, correct spelling, make life easier for ourselves. And because this is a running total and we're going to be adding to what's already in this variable, we need to paste it again in there. So what we're saying, whatever's in running total already, add on to it the results of this calculation, and we'll put the calculation in brackets. So whatever's already in running total, add on to it the result of this calculation, and then store that new number into running total. And that's what allows you to accumulate, rather than just, if you just had a sign and it was a new value, you would just be swapping out instead of a running accumulator. Right, so what is the calculation? So if we were doing this just on a piece of paper, it would be the place value, which is a 1, isn't it? If we're going to count it, it's got a 1 in it, so it would be 1 times base to the exponent, because the exponent is telling you the place order. So what we can do here is say our binary, the name of the array, square bracket, index, because it's that location, and then multiply using the multiply arithmetic operator, base, and up here, remember, we've got a variable called base and we've set it to 2 because it's base 2, that's what binary is. And the exponent in this case will be the index, and the power operator, as we've said up here, the power operator is 2 stars in Python. So 2 stars and index. Okay, and now we can print out our output and check to see if it's working. So I'll put a comment in here, so output conversion result, and we've got a print statement, and we'll say binary, and then we'll add on to that the binary, what did we call that variable? Binary num. And we'll add on to that, decimal. And we'll add on to that the running total, the running decimal, but we need to turn it into a string because at the moment that's an integer. And because we're printing it out as text, we need to cast it as a string. Now I've used a capital D, so I'll use a capital B here. Okay, let's save it and F5 it. Let's do something that we can work out. So we did 6 earlier on, didn't we? 110. 110 should give us a decimal 6. So there we are. We've still got our array, our test array showing up, and we can see that our result is the binary 110 in decimal is 6. Let's put converted to decimal. Right, let's run that again. Let's put in one that we can test. So what will we test for? Let's test for 16. So 16, we don't need an 8, we don't need a 4, we don't need a 2, and we don't need a 1. Should give us 16. Let's test it again. Let's test it for 257. So 256. We don't need 128, we don't need 64, we don't need 32, we don't need 16, we don't need 8, we don't need 4, we don't need 2, but we do need a 1. And we end up with 257. So this program, I would say, is working. You can, once you've got your program working, you can test it a bit more. Good.